Well, I'll try not to use all 10 minutes because we're... Okay, so anyway, we'll start with introduction. So OVS has two different data paths. It has the NetDev data path, Netlink data path. It actually has like dummy data path, and you could think of hardware as a different data path, but let's not get that deep into it. What we're going to talk about today a little bit is related to the Netlink data path. So Netlink data path is decoupled from the main OVS development in the sense that, you know, our commands to control the Netlink data path are done in userspace, or you know, when we choose to use them, it's done in userspace. But most of how the Netlink data path functions is actually in kernel space. So meaning all the packet movement, all the way we connect to the actual devices, skbuff management, etc. That's all kernel space. User space doesn't really care or have to care actually about any of that. The sort of downside or negative side of it is OVS is developed on its own tree, and which is separate from the net tree, because why would you develop it on the net tree? But that does mean that many of the developers who use the Netlink data path or make any kind of changes, etc., they're not paying attention to that tree. And you know, there's different set of maintainers. Those, you know, there's different issues that those maintainers might care about, and different issues that the user space side or the community, the OVS community, might care about, and the two are maybe not overlapping. So, all right, a little bit more on the Netlink data path. It's the kernel data path. It is, you know, it's like I was saying, it's in tree for the kernel. It was accepted in 2011, so it's pretty mature at this point. And the most important thing as well for this talk is it was recently removed from the OVS tree. So OVS contained a copy of the kernel module. It had some places where it diverged, but mostly it was just a copy of Upstream. So yeah, and primarily we interact with that kernel module via the vSwitchd. So we do have a utility, ovs-db Cuddle. It has some disadvantages. For one, it will actually reconfigure the data path when it connects, whether you want it to or not. This can cause problems. So we don't recommend using this utility in conjunction with the vSwitchd. Instead, the way we would request someone interact with it is through the vSwitchd, and that's, you know, via either just the vSwitchd doing its job, you know, which is processing upcalls and you know, handling flows, or if you need to interact with the module directly, OVS app cuddle-dpctl. It's just a front end through ovs-vswitchd. So again, you know, it's kind of repeating the same thing over and over again to drill it in. But you know, one thing is all of the kernel side testing that we do is done via make check kernel, which lives in the OVS tree. And again, this is all a kernel module, and the test suite is contained somewhere else and run by someone else and has a giant, you know, software infrastructure built around it that, you know, has a disadvantage, we'll say. So the issues are, you know, upstream changes are difficult to vet. Kernel maintainers, we just can't expect them to be downloading, installing OVS, making large deployments, you know, running all of the user space utilities and making sure every individual action, match, etc. is working correctly. Individual developers that maybe don't care so much about OVS, but care about other parts of kernel tree and need to do some changes, they, you know, might just make a change in OVS incidentally, part of changing some API or some behavior and break things, they don't know. And they, can't be expected necessarily to be downloading and installing OVS, OVN, making large deployments again. So having a test infrastructure that relies on the OVS user space is a little bit error prone. Yeah, it's difficult to get people to install and use OVS just to test a single patch. So the approach that I took was to create a utility that we can include in the kernel tree, written in Python, that isn't coupled to the OVS user space, and it can run sort of automated to help us test changes. I chose Python over C because it's just easier for extending. Maybe it's also easier if the utility is good enough. We can give it, if someone's having an issue on their system, we can just say, okay, grab this Python code and run it. Maybe that works a little bit better than, futzing with like OVS commands or, yeah, I don't know. The important thing there also is performance isn't really critical. Correctness is more important. So it's sometimes easier to look at some Python code and determine that, yeah, okay, this is going to behave correctly than it is to look at some C code and determine that, yeah, okay, this is going to behave correctly. The initial version is accepted. So this is upstream already in the kernel. There is a single test case already included, and that was used to kind of trap a warn that we emitted, which we shouldn't have been emitting. We can set some feature bits on the data path and other stuff with the upstream version right now. The initial test harness is really just a shell script. It can create namespaces, interfaces, data paths, has hooks for saving traffic. It can detect missing Python libraries. It can detect that it needs the kernel module installed and issues skips, etc. I have some future work that's going on right now. I'm adding the ability to push and dump flows during testing, and probably some more introspection that I'll be adding. So yeah, that'll be good. Pretty easy to run the test, which is, I think, important for me. So it's just a simple sudo command, and this is the output, what it would look like with the current tree. So this is just the Netlink attribute test. You just run, make target equal net openvswitch Kselftest, and it will run the openvswitch self-test. So, yeah, adding a test is pretty easy. Like, this is a shell script that just adds a single test case. Some of this stuff is based on work that's not upstream yet. So like adding the flow is not there yet, and adding the netness and beads isn't there upstream yet, but I do have patches to do a lot of this already. So I'll be posting those soon. And then, again, just making sure your function name is correct. You just add a description and name of the function, and it will basically get picked up and run by the test harness. So, like I said, I have some patches to be submitted, doing some interface configuration and adding some static flows. I have some tests for nested actions and some upcall testing as well that's ready. Future work I'd like to do in the OVS tree. We can maybe deprecate the in-tree ovs-db Cuddle utility once this utility is good enough, so that we can maybe kind of get rid of it and not have bugs related to people running ovs-db Cuddle and reconfiguring their data path. Maybe we could submit some of this work to the Pyrote 2 project, and that way Pyrote 2 would actually be able to also provide Netlink configuration for the OVS data path. Just a thought, something we can do. And then I'd like to maybe use some of this work, share it with Adrian's flow visualization and tracing projects, because maybe it would make sense there, actually dumping some of the Netlink flow data. So, and yeah, that's it. Okay. I guess we have a question.
So, can you hear me? Yeah. You mentioned make check kernel in OVS. What about the one in OVN? And more precisely, how can we help you add more tests? Because I guess you need that, right? We have a lot of OVN tests running with the kernel datapath.
Yeah, so I guess one thing would be once all of the different flow actions and match attributes are in, it would be really nice to have some test cases around those that basically show that the actions are working the way we intend them to work. You know, basically, if you think of each action as a feature, show sort of the use case of that feature. That way, any future changes, we could actually demonstrate that, okay, some future work hasn't broken them, you know, or if they need to change, which they shouldn't because it's kind of a API, but, you know, we can actually enforce that it hasn't been broken.
Okay, that's interesting because in OVN we use them a bit differently. We use them as end-to-end tests, but you actually want to turn them into unit tests. So we should probably discuss.
Yeah.
No questions online.
Okay, more questions.
Do you think we can integrate this with the zero-day bot?
Yes. I think we can. I think we should. So, yeah.
Who's the guy who runs it?
I don't know who runs Zero-Day Bot, but we can talk to that person. We can hunt them down and make it happen.
Okay, thanks.
A kind of related question. So if you look today at the NetDev plus BPF patchwork, we talked about this a bit later, a bit before, but if you look at the NetDev plus BPF patchwork today, you will notice that self-tests are not running on the net tree. So basically, the check is always green, and it says that there are no self-test scripts for net tree. Even though there are obviously the self-tests for net tree. Did you have a chance to look into that or maybe get some information why it's happening?
I haven't looked into that, but it is something that we should bring up maybe to the NetDev mailing list. I mean, at least like for openvswitch, it would be nice if every time someone submitted a patch where openvswitch module was touched, we knew to ran this test. That way, you know, we could get at least some confidence that the change hadn't broken anything. Okay. Any other? We have.
Chat says they think it's the Intel folks who run the zero-day.
So there's two zero-day bots. One is the Intel one, and one is the OVS one. So the OVS one I run.
Okay. That was fine.